Hi, my name is Florence Ofori, and I'm about to give you some takeaways on disease prediction models that I built. So I worked with a data consisting of 10 features and 10 features relating to glucose, cholesterol, and other health test results. And with the target variable showing if a patient has a disease or not. These had 5 categories from healthy to anemia, etc., etc. So after the exploratory data analysis, I trained models such as logistic regression, SVM, neural networks, and I also fine-tuned a large language model, which is the generative AI model. Which is I use Gemini specifically. So what are some of the challenges I had? The data was already scaled, which made it difficult for me to understand what what the numbers were saying in the exploratory data analysis phase. And another big problem was that about 2,000 examples of the data were duplicates. And so training this, I had to take out about 2,000 examples to the extent that the training data became smaller than the test data. And this was not really optimal for training the model. So it got to a point I tried to even swap the training data for the test data, but it didn't really improve model performance, not even for the large language, not even for when I fine-tune the large language models. Some categories were also existent in the test data, but not in the training data. And so I had to take those out as well. So what are my key takeaways? Well, firstly, I'd like to talk about the results. The results weren't so good. Accuracy was about 0.38. The AUC-ROC score wasn't good as well. And even for the LLM results, it was giving me different answers. The prediction results were different from the observed results. I used other techniques such as adjusting some of the hyperparameters like the number of iterations, number of epochs, the solver, etc., etc. I use grid search to help me determine the best hyperparameters to use. I tried scaling the data that I had. I tried encoding the variables, the target variables, but all these still did not improve the model performance. So what are my key takeaways? My key takeaways are that weird data equals weird results. So I got to know that the quality of the data matters when you want your model performance to do well. And if you don't have the quality, then you can either pivot to another project or perform some data collection and get the quality, the quality data you need to make sure that your model trains well and evaluates well, because data is the blood or the life source of machine learning and AI. Thank you.